In this video, I'm going to talk about how to go about solving different synthesis problems. So to first recognize a synthesis problem, you're going to notice that there's going to be a starting product, and then you're going to have two arrows, and then you're going to have the final product. And the whole point of the synthesis problem is to figure out the steps in between that got you from this to this. And just because there are two arrows right here doesn't necessarily mean that there's going to be two steps. There could be 3 steps. There's probably not going to be any more than that. But, you know, the number of the arrows here doesn't actually matter. So the best way to go about these sort of problems is to start not with the beginning molecule, but start with the final product. And then you can see what step it took you to get to there, like what sort of mechanisms you learned that could have possibly gotten you the product. And then you can go from there to figure out how to get back to your starting molecule. So on this one, our final product has 2 double bonds to oxygen right here and a very long chain. And one of the problems, or one of the mechanisms that we learned that formed that is we start with a cyclohexane with a double bond, and the cyclohexane reacts with something like O3 and zinc and water, and it forms this molecule. And without going through the whole mechanism, basically this double bond is cleaved in the middle, and on that carbon and that carbon, double bonds to oxygen are formed, which is how you get the 2 double bonds to oxygen in the final molecule. So now we need to take a look and see if there's any way that we can get from this molecule to the cyclohexane. And from what we learned, there actually is a mechanism that can get us from that molecule to the cyclohexane. And as we learned in the previous chapters, we can do an elimination reaction, and we will react this with H2SO4, which is a strong acid, and that will react with the oxygen and the hydrogen on the OH, and ultimately that will form the cyclohexane. And on synthesis problems, you don't have to show the whole mechanism that goes through it, because there will be other problems where we have to do that. But the whole point of the synthesis problem is to simply show what each molecule reacted with and how they got the final product. You don't actually have to go into detail with the mechanisms. So now on this one we have a final complete synthesis problem. We went from this molecule, reacted it with the H2SO4 and got the cyclohexane with the double bond, and then we reacted that with the O3 and the zinc and H2O, and we got this final molecule. Okay, so for this synthesis problem, we start with a cyclohexane with a bromide ion attached, and we will end up with a cyclohexane with a double bond to oxygen. So from what we just recently learned in class, we know that to get a cyclohexane with a double bond to oxygen, one of the best ways to do that is to start with a cyclohexane with an alcohol attached, and that will end up reacting with a chemical known as PCC, and that will form the double bond to oxygen. So there we've got that step down. So now we need to look and see if there's any possible way we can get from this bromide ion to the alcohol that is attached to the cyclohexane. And there is actually no easy way to go straight from the cyclohexane with the bromide ion straight to the cyclohexane with the alcohol to it. So this is going to be an example of probably a 3-step synthesis problem. So one way we do know how to get to a cyclohexane with an alcohol attached is to simply start with a cyclohexane with a double bond and to react it with an H+ ion and water. And that's a mechanism that we learned a couple chapters ago. So now we need to ask ourselves if there's an easy way to get from the cyclohexane with the bromide ion to the cyclohexane with double bond, and that there is an easy way. And that is, you react this with some sort of strong base, and we will use T-butoxide. And basically that performs an elimination reaction, which we learned about before the second test, and now we have a complete synthesis reaction. So ultimately, synthesis problems require us to go back and remember all the mechanisms that we learned, and it's a way of kind of reviewing in our memory while also tying together everything that we've learned throughout organic chemistry so far. And synthesis problems can be kind of hard, but ultimately if you break them down one piece at a time, like I showed you, then you should be able to get through any synthesis problem. As I mentioned, the keys to solving synthesis problems are to start at the final product and just work your way back, and remember to always ask yourself if there is a reasonable way to get from the starting molecule to whichever one you were at the time, and that will determine how many steps you have in the synthesis problem. And you just keep working backwards until you find a good way to get to the starting material. And that is how you solve a synthesis problem.